Hi everyone, welcome to the class of MBA CAT Fast Test. This is Shubham Jaiswal and we will be continuing our topic from our last video, factorial. So, what is a factorial? Factorial is a multiple of any number n for till n. Let's say you want to find the factorials of 6. 6 will be what? 1 into 2 into 3 till multiply till 6. Let's say if you want to find the factorial of 100, it will be 1 into 2 into 3 goes on till 100. Now, any factorial is made up of a prime number. Let's say 4. 4 is what? 2 square. So the 4 factorial will be 2 into 3 into 4. It is made up of 2 and 3's only. Similarly, for 2 till 6, 6 factorial is made up of 2, 3, 5 and goes on for any number n factorial. Now, since we already know a factorial is made up of prime numbers, how to calculate prime numbers in that factorial? Let's say if you want to find out number of 3's in 21 factorial, you can use this prime factorization method as you write 21 factorial this side, then you divide this by 3, 3 7 is 21, then 3 2 just 6, and whatever is the remainder left, you just leave the remainder. So what is the value of 20 power of 3 in 21 factorial? This whatever the sum of digits comes, excluding these digits, this will be your answer. Similarly, if you wanted to find out number powers of 3 in 29 factorials, it will be 3 divided by 9, 27. 2 will be the remainder. You leave that remainder outside. This is 9, 3 1 is 3. You sum this up, it becomes 13. So the power of 3 is 13 in 29 factorial. Now see, that's it. Moving ahead. Now, number of 2's for any factorial, let's say you take 2 or a factorial for 6 or factorial for any number, the number of 2's will always be greater than number of 3's. Why? Because the 2 comes first and any number, let's 2 into 3 into 4. So 2 is always at first, 3 is always at second, next prime number 5 will come at fifth position and the next prime number after it 7 will come at seventh position. So it will have lesser chances or lesser number of sevens will be there. So always remember this thing that the number of the smaller prime number will always be greater than the number of the greater prime numbers. You will have this wide variety of applications in factorials. Now we come to trailing zeros. What are trailing zeros? What is a zero? First of all, how it is made up of? It is made up of multiple of 2 and 5. So the greater the multiple of 2 and 5 or the greater the sets of 2 or 5 is there in a factorial, that will be the number of trailing zeros. So let's say we have 10 in our hand, it is made up of 1, 2 and 1, 5. Or you can say if there are 100 2's available but 1 5 is available, we could make only 110 from that. So similarly, following this concept only, let's say when the first 10 will come at 5 factorial, because first 5 will come at 5 factorial, so at 5 factorial will have 1 0. Similarly 10 factorial, till 10 factorial 2 5 will come, so two zeros will be there at 10 factorial. 1 0 is added at each multiples of 5 in consecutive factorial of numbers. Let's say this, what does this mean? Ki if 9 factorial has 1 0, so at 10 factorial, which is a multiple of 5, 1 0 will be added. So when 9 factorial has 1 0, 10 factorial will have 2 zeros. Similarly, when 14 factorial has 2 zeros, then 15 factorial will have 3 zeros. 1 0 is skipped at each multiple of 25 in consecutive factorials of numbers. What does this mean? Ki when a 5 comes, it will give one additional 0. So when in 25, two 5s come. So what will happen? Ki let's say 24 factorial has four zeros. So what will have 25 factorial? It will have two more zeros added to it. Now it will have 6 zeros. So 1 0 is skipped. So in each multiple of 25, 1 0 is skipped. Similarly, in when 125 comes, 3 zeros will be added. Why? Because 3 5s are added there. So 2 zeros will be skipped over here. Write most non-zero digit in any factorial. Now, how to calculate this? See, the greater the factorial, the greater will be the number of digits to be multiplied. It won't be easier in mind or in paper to calculate it. So, we have a formula for that, which is n factorial is equal to 5a plus b. You write the number in the form of either 5a plus b or 25a plus b, whichever is convenient to you, and then apply this formula R1 and factorial. Let's say you want to calculate for 77 factorial. What is the rightmost digit for this number? Which means after removing 0, what is the unit, what will be the digit left? That is called the rightmost non-zero digit. So convert this 77 factorial, converting into this form would be complete waste of time. So we convert this in this form. This will be, you can write this as 25 into 3, 25 is 75 plus 2. So the rightmost non-zero digit could be written as in the form of 4 to the power 3, which when multiplied by 3 factorial, which when multiplied by 2 factorial. 4 cube will be equal to 64, which when multiplied by 6, 3 factorial is 6, 3 or 2, 3 are 6 into 2. So now it will be easier, 4 6 are 24, 2 are 48. So the rightmost non-zero digit will be 8. This is it. So this is how the formula helps you. Rightmost last two non-zero digit in any factorial. We also have a formula for this. N factorial is equal to 5a plus b. And if you wanted to calculate last two non-zero digit in any factorial, convert it into this form. Let's say this time we'll calculate for 18 factorial. So you write what? 5 into 3 for 18 factorial we are calculating. So this could be written as 5 into 3, 15 plus 3 will be left. You could write this in the form of 12 to the power a, which will be equal to 12 to the power 3 multiplied by 3 factorial, and then you write it down till you get 1 plus 2 plus 3, which means till b is 3 here. So we 5 3 ja 15, 15 plus 1 it becomes 16 multiplied by 17 multiplied by 18. So whatever the last two digits you need to calculate for this, and then you will get the answer. Powers of prime numbers in 370 factorial. Now, always remember the thing that a factorial is made up of prime numbers. So, if you wanted to calculate the power of prime in that number, you use prime factorization method, and it is valid for only prime numbers. What I mean to say is, let's say if you want to calculate the power of 5 in 370 factorial, what you need to do, you just write 370 like this, make this 5, this goes 74 times, then for another 5 this goes 14 times, 5 2s are 10, that's it. So what is the value? 88 plus 290. So 5 to the power 90 will be there in 570 factorial. Now let's say if you want to calculate the power of 25, don't just divide 25 by 370 factorial. Right, this is the main point I was trying to highlight. Instead, what is 25? It is 5 square. Instead, divide this number 5 to the power 90. So if you wanted to find how many times 25 will be divisible in 370 factorial, so this becomes half 5, or you can write this number as 5 square whole to the power of 45, right? So 45 times 25 would be divisible if you want to divide 25 by 370 factorial, right? This answers our next things, key any factorial divisible by 12. Now, if you want to find how many times 370 factorial is divisible by 12, you just figure out what 12 is made up of. It is made up of 2 square into 3. So, you just need to find the power of 2 square in 370 factorial, which means you need to prime factorize 370 factorial by 2 and by 3. You get the number of 2's, you get the number of 3's. Whatever limits, let's say it has greater number of 2's and less than 3's, so 3 will limit it. So whatever the value of 3 will be there, that is your answer, right? N factorial being a multiple of 4 to the power 24 and 4 to the power 32. First of all, convert into prime factorization, because factorials uh, can be easily calculated by that. 4 to the power 24 would be written as 2 to the power 48. 4 to the power 32 can be written as 2 to the power 64. You just need to find a factorial number which starts with this or starts with something near about this and ends with this, right? Which you can easily do now. Now, the number of trailing zeros given to find factorial is approximately multiplied by 4. Okay. What does this means? Let's say you want to find the number of trailing zeros a factorial with number of trailing zeros 80. So this is a rough, not a this is not a formula. You multiply this by 4. So this will you will get 320. So 320 factorial will have approximately 80 zeros. Approx. Right? Moving ahead. If this is another few things for improving your GK, and if the questions are asked in the examination, you can remember this. If n factorial has n digits, n could lie between 1 factorial. What does this mean? Ki 22 factorial will have exactly 22 digits. 24 factorial will have exactly 24 digits. These are the four numbers available for in the mathematics which have the same number of digits as their factorials. Has less than n digits from 2 factorial including 2 till 21 factorial, they will have the number of digits will be less than the factorial value which they will get. Now, for any other number greater than 24 factorial, which means from 25 factorial and 0 factorial, the total number of digits they have is more than the factorial of what you are finding. Let's say 0 factorial you are finding, it is having one digit. So, and this continues. HCF and LCM. HCF is always a factor of minimum difference between two numbers. See, if you want to find HCF of two numbers, three numbers, or n numbers, you just first figure out which two numbers have the minimum difference, and the HCF of all those n numbers would be either the difference or a factor of that difference. Okay, so this will help to save your time. After HCF is taken from number, they must become co-prime. Of HCF of two consecutive even number is 2. Let's say if you want to find 2, 4, the HCF will be 2, 8, 10, two consecutive even numbers. It is like telling if a number is a 4k form, it will have an HCF of 4. HCF of two consecutive odd number is 1. Always this is the case. 3, 5 you take, 11, 13 you take. HCF will always be 1. To have minimum number of trials, if you wanted to find LCM, you just say multiply the number between, if you want to find LCM of 4 number or 5 numbers, you just read the multiple of bigger number, you will get the answer easily. LCM always takes highest power of primes in the given number. Self-explanatory key. Let's say if you want to find if you have numbers 5, 25, 625, 3125. So what will be their LCM? The highest power which is available in that, which is 3125. The power of 5 in 3125 will be your LCM, which means 3125 itself only. LCM is always greater than or equal to HCF. Always remember this is a fact. LCM is K times HCF. It is LCM is a multiple of HCF. This is basically class 6 mathematics. Factor multiplication of product of two numbers is always equal to HCF and LCM. Now, if a question comes for finding the number of ways in which HCF and sum of two number is given, how to find it? First of all, let me tell you what a Euler number is. Euler number of any n is the number of co-primes which are available before n and they are co-prime to n. Now, what the questions will ask you, it is telling you let the HCF of any number will be k, a plus kb is equal to s is given where s and b are co-primes. So what is it asking you? A plus b is equal to s upon k. If you wanted to find number of ways, you find out the Euler number of this number and then divide by 2 if it is asking unordered, because A and B and A will be same. Then if it is asking for order, you just don't need to divide it by 2. Finding the last two digits L2 for any index in a number. Now you might not get direct question from this, but this will help you in eliminating the options available in the questions. If if the number is of the form 2 to the power 10 or odd power, what does this means? Let's say there is 2 to the power 10 and you can write the number as 25. Okay, this is basically an odd power. So it will have its last two digits blindly. You can write their last two digits 24, 25, 37, 41. Anything if it is an odd power, you can blindly write 24. And if it is for the even power, 25, let's say it is 2 to the power 10. First of all, it must classify this criteria, and here it goes 16. Then you can write it out the last two digits of that number will be equal to 76. Now let's say you want to find out last two digits for number ending in 1. What you will need to do, let's say the number is 2, 4, 3, 6, 1, whole to the power of 48. What you need to do is you need to write 1 at the unit place for the last two digits, 1 at unit place, and whatever will be the product of these two numbers, 6 and 8, which is 48, you just write the unit digit of that number. Now it does not matter it is 48 or 4 or 88, and the unit digit will, if it remains same, the answer will come same. Instead of 6, if this is 7, it will be 7 into 56. So the answer will become, last two digit will become 6 and 1. Yeah, moving on. And for numbers ending in 3, 7, and 9, see, 3 to the power 4 is 81, 7 to the power 4 is 2401, 9 square is 81. So you need to convert the powers in this form, and then you can continue this from the last step when you get the unit digit as 1. For number ending in 5, if the power and tens digit of a number ends in odd, then L2 is equal to last two digits is 75. What does this means? If the, let's say the power is odd, which means power is 35, and the tens digit of a number which is ending in 5, first of all it must end in 5, and tens digit is also odd. Then you write any number over here, it does not matter, 2, 3, 4, this will always end in 75. Or else, if does not happen, if this number or this whole number as a, if this is anyone is even, let's say if this goes even, which means 8, yeah, or this becomes or and this remains same, that this will end in 25. Or if this remains same, this remains 9, and this power becomes, p becomes 36, this will end in 25. Another property which you can remember, LCM of fractions, which is always the LCM of numerators you take, and then you take the HCF of denominators. This you can use it in arithmetic as well, factors. Okay, now we will continue factors in the next video. I hope the learning helps you, and thanks for watching.